Welcome to my channel Chemistry Class. Welcome back to Chemistry Class, my dear student. I hope you are doing well. So, in the previous lectures, we discussed about the pH scale and pOH scale, which help us to understand whether a solution is acidic or basic. Now, my dear student, today we are going to talk about a very special and balanced type of a solution, which is neutral solutions. My dear student, this type of solution is neither acidic nor basic. So let's understand them step by step. Introduction to neutral solutions. My dear student, a neutral solution is one that has equal concentrations of hydrogen ions, mean concentration of H positive ion, and hydroxide ions mean concentration of OH negative ion. In other words, the amount of acid and base in it is the same. Therefore, the pH and pOH values are also equal in a neutral solution. My dear student, at 25 degrees centigrade, concentration of H positive ion is equal to concentration of OH negative ion, which is equal to 1 multiplied by 10 raised to the power minus 7 m. Hence, pH is equal to 7 and pOH is also equal to 7. Now, definition of neutral solution. My dear student, a neutral solution is a solution in which the concentrations of hydrogen ions mean concentration of H positive ion is exactly equal to the concentration of hydroxide ion mean concentration of OH negative ion. Example, pure water mean H2O is the best example of a neutral solution. Now, chemical explanation of neutral solution. My dear student, when water molecules slightly ionize, they produce equal numbers of hydrogen ions and hydroxide ions. Reaction H2O, which is reversible gas, H positive ion plus OH negative ion. Here, for every H positive ion formed, one OH negative ions is also formed. So both ions have equal concentrations. Mean concentration of H positive ion is equal to concentration of OH negative ion, which is equal to 1 multiplied by 10 raised to the power minus 7 m. Now, calculation of pH and pOH for neutral solutions. My dear student, we know that pH is equal to negative log of concentration of H positive ion and pOH is equal to negative log of concentration of OH negative ion. Now, since concentration of H positive ion is equal to concentration of OH negative ion, which is equal to 1 multiplied by 10 raised to the power minus 7 m. So, pH is equal to negative log and to 1 multiplied by 10 raised to the power minus 7, it is equal to 7. And pOH is equal to negative log into 1 multiplied by 10 raised to the power minus 7, which is equal to 7. Restrain here only we put the value of concentration of H positive ion and concentration of OH negative ion in a formula. So, and pH plus pOH is also equal to 14. Hence, the solution is neutral. Now, characteristics of neutral solutions. First one, equal concentrations of ion. When concentration of H positive ion is equal to concentration of OH negative ion. Second one is pH is equal to 7. On the pH scale, a neutral solution always has a value of 7 at 25 degrees centigrade. The third one is equal to neither acidic nor basic. It doesn't turn blue litmus red or red litmus blue. The fourth one is no excess ions. The solution doesn't have excess H positive ion or OH negative ions. Fifth one example, pure water H2O. Second one is sodium chloride in NaCl solution and water. since NaCl is a salt of strong acid and strong base. Examples of neutral solution. Example, pure water in H2O. Reason for neutrality, because equal concentrations of H positive ion and OH negative ions. Second one is sodium chloride in NaCl solution. Reason for neutrality, as this formed from strong acid HCl and strong base NOH. Third example is potassium nitrate KNO3 solution. Reason for neutrality is formed from strong acid HNO3 and strong base KOH. Now, graphical representation of neutral solution. When you student, a neutral solution as has pH value is 7 and pH value is also 7 on scale. Now, ionic product relation. Ionic product relation. In pure water, H positive ion multiplied by consolidation of OH negative ion is equal to 1 multiplied by 10 raised to the power minus 14 at 25 degrees centigrade. Since concentration of H positive ion is equal to concentration of OH negative ion, you can write concentration of H positive ion square is equal to 1 multiplied by 10 raised to the power minus 14. It means that concentration of H positive ion is equal to under root 1 multiplied by 10 raised to the power minus 14, mean taking square root on both sides. Now, concentration of H positive ion is equal to 1 multiplied by 10 raised to the power minus 7 m. Thus, water is neutral because both ions are equal in concentration. Effect of temperature on neutrality. When you student at temperatures other than 25 degrees centigrade, the ionic product of water mean water dissolution changes. For example, at higher temperature, water dissolution mean Kw increases, so both concentration of H positive ion and concentration of OH negative ion increases equally. Although pH may not be exactly 7, the solution still remains neutral because concentration of H positive ion is equal to concentration of OH negative ion. Hence, neutrality depends on equal ion concentration, not just on pH is equal to 7. Important note: registering F concentration of H positive ion greater than concentration of OH negative ion, the solution become acidic solution. F concentration of H positive ion less than concentration of OH negative ion, solution is basic solution. F concentration of H positive ion is equal to concentration of OH negative ion, solution become neutral solution. Now, real life examples of neutral solution. First one, distilled water used in laboratories. Second one, salt solution such as NaCl in water used in saline injections. Third one, rainwater pure when it is not mixed with acidic gases. So, my dear student, this is all about today's lecture, a neutral solution. I hope you understand. So, if this lecture will help you, then don't forget to like the video, subscribe to the channel for more chemistry lectures, and share it with your friends. To answer your question below. Take care and see you in the next class, inshallah. Thank you for listening.